Hi all, today we'll be talking about a Leetcode problem, number of islands. Let us go through the problem statement first. Given an m cross n 2D binary grid which represents a map of ones and zeros, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So what does this mean? This means that we are given a 2D matrix containing ones and zeros, and we need to find the number of connected components in this matrix. Why connected components? Because it says that an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So if we see in the first example, these ones are connected horizontally and these ones are connected vertically, the zeroth column and the first column. So basically all of these form under the same connected component. Even this one is connected vertically. Here we are only considering vertical and horizontal directions. So this will have only one connected component, hence our number of islands would be 1. Similarly, in the second example, there are 1, 2, 3, 4. These are connected horizontally, these are connected vertically. The rest all are surrounded by zeros, and this one is lying diagonally, but diagonal elements do not form the same component. We have to consider only horizontal and vertical direction. So this will be the first connected component. Element 0, 0, 0, 1, 1, 0, 1, 1. The second connected component will contain only one element, which is element at 0, 1, 2, 0, 1, 2, 2, 2. Because it is not connected horizontally or vertically with any other one, it is only connected diagonally, and we are not considering the diagonal elements as given in the question. And the third connected component will be uh, these two elements. These are connected horizontally. So basically we are given a graph and we need to find the number of connected components in the graph, and this can be easily done with the help of BFS. Let us deep dive into code. We'll store n, which will be the number of rows in our grid. We'll store the number of columns in M, grid 0 dot size, and then we'll keep a visited matrix, Boolean visited, n m, and we'll initialize this matrix with false. That is, initially all the elements are unvisited. We haven't visited any element in this matrix. We need to keep track of this visited matrix so as to remove redundancy. We don't want to be visiting the same cells again and again, either through horizontal or vertical direction. We might come across a visited cell. So, like in the first example, if we start our BFS from here, we'll be visiting these all the cells which are connected to it. So once we go to the next cell, we don't want to start a BFS from here also, because we already visited the cell 01 when we had started the BFS from cell 00. Thus, in order to reduce this redundancy of computation, we want to keep a visited matrix. So visited I J will be false. So we have initialized all to false. Now we'll write the loop where we'll perform BFS over this matrix. So when are we going to start the BFS? We are going to start our BFS when the element in grid ij is equal to 1. That means it is a land and not a water cell, and we should not have visited this ij earlier. Like if we have already visited it in some other traversal, that means we have already processed this node. We don't need to process or start a BFS from this node again. So if it is not visited, if these two conditions satisfy, we can go ahead and do our traversal. We'll also keep an int c initialized with 0, and finally we'll be returning the C. This will store the number of connected components that we got in this graph. So if we have started a BFS from this cell, that definitely means that it will form one connected component. However number of cells this connected component might have, we will have one connected component uh, every time we enter this if condition. Now we'll initialize a queue. This queue will contain our I and j. So we'll keep this will contain the index of the row and column that we are currently at. So we'll keep it as pair. We'll push the initial ij. We are starting the BFS from ij, so we'll push it and we'll mark visited ij as true. Then, while this queue is not empty, we'll keep popping elements from this queue. So we'll store the x component of the row index in u, which will be q dot front dot first, and the y component or the column index in v, which will be q dot front dot second, and we'll pop this element because we have already processed this node. Now if now from this cell we can move in 4 possible directions: upwards, downwards, left and right. But first we need to check whether we have any valid cell upwards or towards the left or towards the right. For like I equals to 0, we have no row before it, or for j equals to 0, we have no column before it. For I equals to n minus 1, we have no row after it, so downward direction will be invalid. And for j equals to m minus 1, again we have no column after it, so so we can't go right from the last column, or left from the first column, or upwards from the first row and downwards from the last row. So just to check this validity conditions, we'll check if is valid. We'll push u, v, n, and m to this function. We'll pass u, v, and m to this function. So is valid int u, int v, int n, int m. First, let us traverse the upward direction. So we'll do u and v minus 1. Now we'll return u greater than equals to 0, and u should be less than n, and v should be greater than equals to 0, and v should be less than m. So if these 4 AND conditions are satisfied, this means this u plus u and v minus 1 cell is a valid cell, so we can move ahead. And if this u and v minus 1 is not already visited, then only we need to go into this BFS, as well as the grid u and v minus 1 should have the value of 1. Then we have found a valid node, and we'll push this cell into our queue. So v minus 1 is basically the left direction, one column before it, one column before the cell, and we'll be passing u and v minus 1 as true. Now we have already visited the cell, so we don't need to process the cell again. Similarly, we'll check for the right cell from the current cell, that is the cell towards the right of the current cell, which will be u and v plus 1. Then we'll process the up, upward cell, which will lie in u minus 1 v. And finally, the downward direction, which will be u plus 1 v. So we have explored all the four cells, up, down, left and right, and we are computing our result in C. Looks good to me. Let's try to compile this. Let us check on all the example cases. Looks good. Let us try and submit this. It is accepted. Thank you so much for watching the video.